Good morning to everybody. My name is Giuseppe Landolfi, and I'm here today to talk about the SDO, that stands for Sustainability Driven Orchestrator, which is one of the main outcomes of the task 5.2. The SDO is a web application based on a specific methodology, able to provide a set of functionality for analyzing the overall environmental sustainability of the ecosystem. Moreover, it supports DRP in understanding which is the best supply chain able to provide a set of processes for a specific product. What about the work done so far? We develop a web application for defining the list of processes provided by supplier according to a sustainability point of view. We define the integration aspect between DRP and SDO. We develop a first version of the REST APIs for allowing the DRP to exploit the sustainability services. And then we provide some backend functionality for gathering and exporting data from and to the platform repository via the CRUD APIs. What about our next steps? We need to complete the development of the exposed REST API. We need to support the DRP integration. And once ready, we need to integrate the SDO with the platform repository by means of the CRUD API. In order to better understand how the SDO works, it could be useful to see the overall system architecture. According to this architecture, we can see that the DRP module uses in the design tool output, the manufacturer characterization, and the SDO results for detecting the best supply chain considering costs, time, and environmental impact in order to drive the production process. Now, let's see the demo.
Thank you, Giuseppe. Now I will briefly show you the demo of the SDO. The SDO allows the calculation of environmental indicators for a list of processes. So, first of all, we add our first process, for example, injection molding. Clicking on Add Process, injection molding. Okay, perfect. Add. I can specify my custom name of the process and the group. So, for example, injection INEDIT, for example, from machine 1. And clicking on the process row, the user has the possibility to personalize data from process environmental databases, so the life cycle inventory background data, to obtain environmental indicators that are actually representing today's impacts of the manufacturing process. So the life cycle impact assessment background data sets, so for example, EcoInvent, are personalized through a Pareto approach. So highlighted in green, you can see which inputs in the process have the largest impacts and the percentage of the impacts contribution. I use the default quantities for the first calculation. So I click Done. After the modeling phase, when integrated, the ERP will invoke the calculation, making comparisons on the results. But here I can show you some example of this kind of results. Selecting a methodology, so for example, IPCC 2013, and clicking on Calculate. These results are climate change environmental impacts with kilogram CO2 equivalent unit of measures. Please remember the result of the first indicator, so the 9.46 times 10 minus 1 kilogram CO2 equivalent. Now, if a producer uses a more efficient electrohydraulic press with a far lower consumption of electricity, for example, from 1.48 kilowatt hours to 0.75 kilowatt hour per kilogram of injected plastic, I will expect lower environmental impacts because electricity is the most impactful input. To be clear, these are a list of all flows for the injection molding process. So I change the quantity for the electricity, and now the SDO can recalculate impacts considering the modified life cycle inventory, so the LCE data. So I click done, perfect. And I click on calculate. As we expected, now for the first indicator, we have 6.5 instead of 9.46 times 10 minus 1 kilogram CO2 equivalent. So lower impact as we expected.